And then you guys, we're going to be working on page 18 of the packets. We're going to be learning something called L'Hopital's rule. If you were in AP Pre-Calc last year, you actually saw this, but if you weren't, it's okay. It's pretty straightforward. There's just some specifics on how we have to write our answer, how we have to present our answer. Actually, page 17 is where we're going to be. Okay, so we've seen these things before, but there's something called, in math we have something that's called the indeterminate form. Indeterminate means like you can't determine it, so it's versions of a number or numbers that we don't really know what they're going to equal, and usually these show up when we're taking limits. The most common one that we get, and you guys saw this all the time in pre-calc, and we saw it this year a lot, is when you're trying to evaluate a limit and you get 0 over 0. And so that's not 1, it's not 0, it's not undefined. It could be anything, because it could be 5, it could be 1/2. It could be all these different kinds of things, because it doesn't actually equal anything. We don't really know. There's a few other versions of the indeterminate form, which are listed there. So infinity over infinity, 0 times infinity, 1 to the infinity power, infinity minus infinity, infinity to the 0. What L'Hopital's rule is going to help us out with is when we are doing a limit and we're getting 0 over 0 or infinity over infinity. But I'll say it's mostly just 0 over 0. We should not need L'Hopital's rule for infinity over infinity, and I'll remind you guys of why, but we're already pretty good at doing that. You just look at the degree of the top and bottom, right? Top heavy, the DNE, they're balanced, divide the coefficients. Bottom heavy, it's 0. Okay, now if a limit as you evaluate it does not equal 0 over 0, you get some sort of number, or you get 1 divided by 0, or 0 divided by 1. Do not use L'Hopital's rule. We know how to evaluate limits. You guys are already really good at evaluating limits. This is just a way to make life easier for some of the tricky ones. We already know how to deal with a lot of the tricky ones. This is just a faster and better way. So here's L'Hopital's rule. It's right there. If a limit that you're doing, that's some sort of quotient here, is 0 over 0 or infinity over infinity, then you can find that limit instead of factoring, instead of multiplying by the conjugate, by taking the derivative of the top and bottom separately, and then finding the limit of whatever's left. And you can actually use it on repeat. And so let me just show you what this looks like. So for example, number 1 here, if we plug in 2 to the top, we get 12 minus 14 plus 2, which is 0. If we plug 2 into the bottom, 2 minus 2 is 0. Here's what you don't ever want to do. Don't ever write something equals 0 over 0. Don't even write 0 over 0 anywhere on your paper. Okay, don't do it. You will automatically lose the points from me and on the AP exam. Okay, because 0 over 0 is not a thing. You can't say it. Here's what we need to write. In order to use L'Hopital's rule, we need to write the limit of the top equals 0 and the limit of the bottom equals 0. Okay, now, let's rewind a couple months. Let's say it's September or August. I'm asking you to find this limit. What are you probably going to do when you get 0 over 0? Factor. You're going to factor. You're going to cancel out x minus 2. You're going to get the answer. It's going to work. Great. If you prefer to factor this, go ahead and factor it. It will still work. Sometimes L'Hopital's rule is just a little bit faster. Sometimes what slows you down is going to be writing these two limit statements right here, because you do have to do this if you're going to use L'Hopital's rule. So there's pros and cons, but especially the more complicated the limits get, the easier L'Hopital's is. But L'Hopital's rule just says that we can now reevaluate this limit by taking the derivative of the top and bottom separately, not using quotient rule, not doing the derivative of the whole thing, just the derivative of 3x squared minus 7x plus 2, which is and the derivative of the bottom separately, which is? What's the derivative of the bottom? 1. Yep. And so now if you plug 2 into that, you get 5, which is the answer. And usually just taking the derivative is easier than factoring. We can just go ahead and check this real quick though. If we do factor the top, we know it's x minus 2 times 3x minus 1. So if I was going to do it this way, cross that off, plug 2 in, I still get 5. So it works. It works. But sometimes it's faster. Especially if I was doing something like this. How would we have taken the limit, this limit here? First of all, check, plug in -3, make sure it's 0 over 0. 0 on top, 0 on bottom. Okay, yes. What would we have done back in August to deal with this one? Yeah. So we would have to have done this. It's not the worst thing in the world, but it's on the list of the worst things in the world. So it's not. I don't like making you guys multiply by the conjugate when I know that L'Hopital's rule works. I'm sure you don't like it either. So we don't have to do that. But what we do need to do is write this. We need to say the limit as x goes to -3 for the top equals 0, and the limit of the bottom equals 0. We need to write those, or we can't use L'Hopital's. We're just not allowed to. We'll just lose a point. So. So once we say that, now we can just take the derivative of the top and the bottom separately, again, not using quotient rule, because I'm not taking the derivative of the whole function. I'm just doing the top and bottom separately. Derivative of the top is 1. Derivative of the bottom is a little bit more complicated here, but it's just 1 over 2 root x squared minus 5 times 2x. That's the derivative of the inside. I can write that a little bit neater. 1 over 2 root x squared minus 5 times 2x. So all of that's on the bottom there. And now when we plug in negative 3, so remember once you go to plug in the number, this is when you get rid of your limit notation. So it's 1 over negative 6 over 2 root 4. So that's negative 1 over negative 6 over, sorry, not negative, okay. 6 over 4. So that's just 4 over 6, or negative 2/3. Yeah. That's the idea. That's really all there is to it. We'll do some practice with it, but any questions? Okay. One thing is you can use it, you can keep using it, like if it's true. So let's say, whenever I see something like that, that's crazy looking, it might be a little annoying to plug negative 2 in just to verify that it's 0 over 0. It is annoying to do that. Just do it. You can just do it in your head as well as you can. So like negative 8 plus 4 plus 16 minus 12. Okay, that's 0. And yeah, it is annoying to write this out. But what's more annoying, writing that out or trying to factor those? Doing your rational root theorem or factoring by grouping or whatever it is. That would be really annoying. So that'd be negative 8 plus 32 minus 40 plus 16. That sounds like it would equal 0. Maybe I'll just take a risk and say it equals 0. Maybe I don't feel like actually plugging it in. I'm just assuming. So we do the derivative. 3x squared plus 2x minus 8. 3x squared plus 16x plus 20. Plug negative 2 into that. 12 minus 4 minus 8, that's 0. 12 minus 16 plus 20. That's 0, right? Let me make sure my math is good. Does the bottom equal 0 when we plug negative 2 in? Okay. So, we can use L'Hopital's rule as many times in a row as we need to. Because imagine that this was your original function. If that's the original problem and you got 0 over 0, you'd use L'Hopital's rule in that. So we just do it again. We have to say the limit of the top equals 0, the limit of the bottom equals 0, and then we just do the derivative again. So 6x plus 2 over 6x plus 16. Hopefully I did this right. So however many times in a row you got to use it, use it. If this shows up as a multiple choice question on the AP exam or one of our quarter tests, you don't have to write all this. You can just take the derivative of the top and bottom and see what it is and pick the right answer. But anything besides the actual AP exam or one of our quarter tests, make sure you are showing this work, because if it shows up on an FRQ, you do have to do this to get full points. You have to say the separate limits. Okay. You guys do number 6. Ready, set, go. I guess one thing to note about this one too is if I'd asked you to do this in September, what would you have done? The right answer is cry. And give up. But now you can't. Now you can do it. All right. Did we get this? It equals 0? Okay. So again, I've said this a bunch of times already, but I'm just going to keep saying it. Make sure you write these two limits separately. Limit at the top equals 0, limit at the bottom equals 0. Then we can use L'Hopital's rule, take the derivative of the top and bottom separately. When we do the top, we do have to use the product rule on this first thingy right here. Make sure you use the product rule. But we get 2x sine x plus x squared cosine x minus sine of x. All over 1. Once we plug 0 into that, it just evaluates to 0. Questions? Okay. Last couple things, and then we're donezo. You should not need to use it for infinity over infinity, like I mentioned earlier, but just to illustrate it here. What is the limit here for number 1 in type 4? 2/3, yes. L'Hopital's rule will work, just there's no need. It's balanced degree, so you just reduce the coefficients. They're both x cubed. This is because we're approaching infinity. So we need to be approaching infinity to do this. But that's the only time you're really going to get infinity over infinity with L'Hopital's. Number 2, what does this one equal? This one is 0. It's bottom heavy. How do I know that? Because e to the 5x grows is the fastest growing function. E to the x is the fastest growing function other than x to the x. The bottom's growing way faster than the top. Exponential growth is faster than polynomial growth, so this is bottom heavy, which means it equals 0. Imagine the bottom is getting huge. It's like a trillion or whatever, and the top is just like a million or something like that. It's basically 0. Okay. There's lots of other examples that you can do L'Hopital's rule with. Do make sure that you only use it when you're getting 0 over 0. Don't use it if it actually equals a number. I love, on a quiz to give you like 3 limit questions, and 2 of them you have to use L'Hopital's rule for, but 1 of them you actually can just plug the number in, and you get the right answer. So just be aware. And then also, if you decide that you would rather factor, that's great. Do that. Just make sure you use your limit notation, but all of your old limit techniques still work. Okay. So that's it. You guys have a Delta Math for that, and we'll have a quiz next week. Yeah.
Will there ever be a time on like the AP test where they ask for us to multiply it like by a conjugate?
No. Nope. Yeah. Good cue. Get up.